So we are starting off our notes today talking about the slope of a line, which you guys have been talking about quite a bit for the last couple of years. The slope of the line measures the steepness of the line. So the slope of the line measures the rate of change, which actually this phrase right here, rate of change, is pretty much what we're going to be using for the rest of the year. We'll say slope occasionally. Really, rate of change is what we're going to be saying a lot more often. So it is written as a ratio, which if you've forgotten, a ratio just means it's a fraction of the change in y to a given line and over the change in x. Think of the slope of the line as the line's movement, and this will help you to remember what it signifies. Slope is symbolized using the variable m. Now, in a straight line, which is what we're doing for this unit, the rate of change is constant. So what that means is it's always the same amount for the rate of change, which is why it makes a straight line. So if I look at my little triangle here, here's my diagonal. If I were to find the slope of this line is always increasing by the same amount, which is why we say it's a constant. When you have a decreasing line, it's always decreasing by the same amount, which is why we say it's a constant. So here's our slope formula. Again, we use m. We call it rise over run. You may have heard that phrase a lot. Change in y over change in x. If you actually needed to calculate it out, it's y2 minus y1 over x2 minus x1. You find how your y's change by subtracting them, find how your x's change, and then set up your fraction. Now, if you actually have graphs like this, it's a little easier to figure out your slope because you just got to pick 2 points and count. So this one, first of all, when we look at the line of this, what kind of a slope is this going to have? Positive, so this is a positive slope. Again, we know it's positive because as I go from the left side to the right side, my line is increasing. My line goes up. So then to actually calculate it, as I said, pick 2 points on the line. So I'm going to pick that point and that point, my x-intercept, my y-intercept. And you count up first, so we go up 1. And then over to the right, how many? 2. So the slope of this line is 1/2. You always are going to go to the right. So you start with your point on the left, always going to your right. So for our second one, what kind of slope is this one? This one is a negative slope. So again, to actually calculate it, I'm going to pick 2 points. And again, we start at the point on the left. So this time we have to count down 1, 2, 3. So this is a -3. And then to the right, 2. Bless you. So -3/2 would be our slope for that one. Always going left to right, just like when you're reading a book. So then down here we have our 2 special ones. What kind of a slope is this one? 0. If you were to calculate it by actually picking your 2 points, you would pick 2 points. Do they rise at all? No. So our rise would be 0 over, and in this case it would be 1, 2, 3, which 0 over 3 is how we get our slope of 0. And then our fourth one, this is an undefined slope. So if you were to calculate it, again, you pick 2 points. It rises up 3, but does it go to the right at all? No, so that means your run would be a 0, and you can't have a 0 in the bottom of a fraction. That's just, no. Which is why this is undefined. Did you guys watch the Slope Dude video last year? And kids talking about it all the time last year when I had them in 9th grade. But you can always remember slope due to figure out positive, negative, 0, undefined. Yeah. So our slope formula, I did give it to you on the front page. y2 minus y1 over x2 minus x1. So if you have 2 points, or if you have a table like our examples down below, you would actually have to use that formula in order to calculate your slope. Now the 2's and the 1's just tell you which point it's coming from. So if you have a table, you want to pick 2 points off your table. I like to use the top and the bottom. So then this means my top point, there's my x1 and my y1, because that's from my first point. Down here, that's my x2 and my y2, because that's from my second point. And then we just plug it into our formula. So m equals y2 minus y1. So my y2 is a 13 minus my y1, which is a 4. And then it's over x2 minus x1, so 3 minus a 0. So what do we get when we do 13 minus 4? 9. 3 minus 0? 3. Can we divide 9 by 3? You sure can. What do we get? 3. So our slope for that one was a 3. Let's try the next one. So again, I'm going to pick 2 points from my table. I like to use top bottom. So now when I plug this in, I have negative 1 minus negative 1. And you got to make sure you put both those minuses in there. So a lot of people, though, forget that the formula has the minus. And then when they go to plug the negative 1 in, they think they already do it, but you got to have both of them in there. And then it's over 5 minus a negative 3. So as you guys said, yes, minus a negative makes it positive. So negative 1 plus 1, 0. 5 plus 3 gives me an 8. But as we said on the first page, 0 over 8 is just a what? 0. So our slope for this one is 0. Let's have you try the third one. So when I did all my math here, I ended up with a 13 over 0. And I see a lot of you did what I expect you to do, which is not the right answer. 13 over 0 is what? Undefined. You cannot divide by 0. A lot of people wrote that the answer was 0. It is not. When 0 is in the denominator, that's undefined. Because you got to think about it. This just means you're trying to, the whole rules of division. If I have 4 things, I can divide it into 2 groups. That works. If I have 4 things, let's say 4 cookies, I cannot divide 4 cookies into 0 groups. It doesn't happen. It's undefined. So that's why we can't have a 0 in the denominator. Okay, the table below shows the rates to rent a lane at the Thunder Bowling Alley. Use the information in the table to find the rate of change and indicate the correct units. Interpret the meaning of the slope in this context. That's a big thing right there, in this context. They love to do that now. Give you a word problem, you have to write your answers in context to the problem. So first thing we have to do though, however, is we have to find the rate of change, which if you remember, your rate of change is your slope. So what you have to do is find your slope of your table. So just like we did up above, pick 2 points. Let's have you go ahead, calculate your slope for this. Hopefully you got a slope of negative 1. Everybody get a negative 1? Woo! Alright, so we got our first part. Find the rate of change. Check. And we need to indicate the correct units. That's the tricky part for a lot of people. So what we have to remember, going back to our definition of slope, slope is your change in y over your change in x. So to get our correct units, we have to remember which one is our y, time or cost? Cost. So for this problem, it's cost over time, which is in hours. So for this problem, when we're doing our slope, that's how much we're paying per hour. So our correct units would be -$1 per hour. That would be finding our slope using your correct units. The other part, though, wants us to interpret the meaning of the slope in context. So since our slope is a negative, what does that mean is happening to your costs? It's going down. So this means our cost per hour decreases the longer we play. So really what the bowling alley is trying to do is give you, a break if you play longer, which they want you to play longer because then you get, they end up getting more money in the long run. So what they're doing is you end up paying less per hour the longer you play. And that's writing it in context of the problem. All right, 5, the table below shows the rates for a cell phone plan. Use the information in the table to find the rate of change and indicate the correct units. Interpret the meaning of the slope in this context. So same exact kind of problem. So go ahead first, calculate your rate of change. Hopefully you got 60. I see some head nods, good. So now we need to write our correct units. It's 60 what? Something per something. What's our y? So this is going to be $60 per month. So there's our slope with the correct units. So we have to interpret that in context. No, what this means is you are paying $60 per month. So the amount you pay keeps increasing. So you have to pay $60 per month. So this rate of change would actually be a constant rate of change because you're always going to be paying $60 per month. It's not going to switch and be $75 one month, $40 the next month. It's a constant $60 per month. All right, so we're going to practice some graphing now. There's a couple different ways I'm going to teach you how to graph lines. There are scenarios where one way works better than the other way, and I'll explain to you when those scenarios are going to happen. So the first way we're going to practice is using your slope-intercept method. So in order to use the slope-intercept method, you need to first remember your y equals mx plus b. That is your slope-intercept form of a line, y equals mx plus b. We call it the slope-intercept form because you can find right away what your slope is and what your y-intercept is. And then once you can get those two things, you can graph. So let's take a look, for example, graph number 1 here. I don't have it in mx plus b form just yet. I need to move something. I need to move my 4x over to the other side of the equal sign. So in order to move it, I need to subtract it since it was a positive 4x to begin with. I get y equals a negative 4x minus 3. So when you go to graph using your slope-intercept method, you need to state what your m and your b values are first. So what is the m value of our line here? But when we write it here, we want to state negative 4 over 1. And then our b value? Negative 3. So let's go ahead and graph this. So on our y-axis, we're going to go down to negative 3. And we put our first dot. Since it's a negative slope, remember you're going to count down 4 to the right 1. Down 4 to the right 1. When it's negative, it's always down. You always are going to the right. You only need 3 points to make your graph accurate. So once you have your 3 points, you can use a ruler or a straight edge of some kind to make your line. And then what you want to do is you need to extend your line so it goes through the entire graph. No little itty-bitty lines around your 3 points. It's got to extend to the end. And then we have to label. So y plus 4x equals negative 3. You always, always, always need to label. Well, really, they've actually changed it. It doesn't matter. You could label it with the original or you could label it with this one. As long as it's labeled with one of them. All right, graph number 2. Let's try this one. So again, need to get y on its own. Not there yet. So what do I need to move first? The 6. So I get 3y equals 2x minus 6. And then we want to do what? Divide by 3. Now I can't actually divide 2 by 3, so I'm going to leave it as the fraction 2/3. So that gives me 2/3 x. And then I can divide 6 by 3, so I'm going to do that. So it gives me a minus 2. When you're going to graph these things, you got to separate them like that. So what's our slope this time? 2/3. Our b value would be a negative 2 this time. So I'm going to start at negative 2 on my y-axis, put my first dot. So then I'm going to go up 2 to the right 3. To the right 3. Then again, you just need at least 3 points to make it accurate. And then you got to make sure you label your line.